So we have that one fixed. We can return the cover. And I think we are fine like that. And that is good. Now we have this other LED light. This is a different one. I had already opened it, and this one is kind of like a backup. I've already opened this one, and this is a little bit more complicated. As we saw, the other one has a differential power supply, but this one has a true power supply with a true ground. And there is the power supply, and there is a battery, 18650 battery, lithium ion battery, that is used for backup, so that you can have light whenever you have a power outage. Now this is how this is wired. We have 3 wires here. This is a ground. This is the power supply, the one in the middle. It is the power supply from the battery, the backup battery inside here. And this one is the mains power supply that comes from the this power supply cam charger, because this also charges the lithium ion battery and supplies some of the LEDs with a voltage. This is how this works. These are 2 different sets of LEDs. Now there are these 2 inner rows, this inner row and the other row at the middle. Now those 2 rows are pairs connected, parallel pairs connected in series. Like this LED and this LED and this one are in parallel and are connected in series to another parallel pair of this LED and this one. So these are the 2 inner rows are 24 LEDs connected in parallel pairs. I will demonstrate. The voltage is applied here, and then this is connected to that one and that one, and then this one is connected to that one, and it's like that and like that, and this one is connected to that one. Okay, and this one is connected to that one, and then to that one, and then to that one. Okay, like that. And these are, they are connected in parallel pairs. And then the final one here is connected to the negative voltage. Now, there is that, and then we have the outer row of LEDs. So these are all connected in parallel, and this is supposed to be about 3.6 volts across each LED, because they are in parallel. It's an 18650 battery. There's a power supply of about 100 volts on these inner sets. That one comes from the adapter or the power supply directly from the mains, and it's about 100 volts. So each pair of LEDs gets about 9 volts, 9.1 volts. Now, the single outer ring of LEDs, the outer set of LEDs are all connected in parallel. They are parallel to each other, and although they share a common ground with these other LEDs, the positive side of the power supply to these LEDs comes from the battery, which supplies a standard 3.6 volts. So whenever we have a power outage, these inner LEDs do not work, but the outer ring of LEDs work. When we have the mains power supply, these outer LEDs are usually off and only the inside ones work. So this is how this kind of bulb works. Now, the most common failure mode for these LEDs is one LED fails, especially on the series circuit, and once one LED fails, the bulb does not work. So what we do, we give it the same treatment to whatever we did with the other light. But when I look at these LEDs, I don't see any faulty LED. They all look almost brand new. We have ground. We have 58 volts. We have 60 volts. 60 volts is not enough for these LEDs. So we will measure the voltage across each pair. At the beginning we have 60 volts, and across this pair we have you see a little bit of light from the LEDs when I use my meter, because the meter provides some ground at that point. Okay, we have 51, so 9 volts across that LED. Then we have 38, about 12 volts across that one. And then we have 24. Then we have okay. Then we have 24, and then we have 10, and then across this other pair we have only 1 volt, and then you have 0 volts. Why do we have 0 volts? It takes the forward breakdown voltage of many LEDs is about 0.7 volts, and once the voltage gets below that, the circuit is broken. So this is 0.1, so you do not, the next pair does not have any voltage. That means that this is why the whole circuit is broken, because the final part of the circuit has not yet attained the forward breakdown voltage of the LEDs. The forward breakdown voltage is the minimum amount of voltage where the LED will conduct current. Okay. Now for there is I think there is you can go and do a little research about LEDs and the PN junction, and that is where you will understand why beyond this point we do not have any voltage. Now we will do something. We will attempt to now we will use a jumper, and we will try from this point where we have 9 volts. We will make a connection between here and bypass these LEDs and connect this half of the circuit to ground, and you will see that some of the LEDs on this side will work, because on each pair of LEDs there is sufficient voltage. Okay, and I'll use this jumper. And you can see you have half of the LEDs working. Why? It's because the supply voltage is not sufficient, and these other LEDs are not faulty. You can also supply them with voltage. We can connect the positive side and bypass some of the first LED pairs to supply the voltage to about 8 pairs, and you see that you will have light. The blinking shows that the voltage is still not enough, so we will jump another pair to this point. There we have it. You can see the first few pairs do not have any light, but we have we have light in the rest of the pairs. So the problem here is that the voltage is not enough. For the 12 pairs we need about 100 volts, about 9 volts across each pair, and here we have we have 60 volts, which is not enough. Of course, on the battery we have nothing. If we were to unplug this one, now the battery is switched on. When we remove this from the mains, and you can see we have on the battery we have 0. On the battery we have 0. So it's obvious the battery is faulty. You cannot have 0 on a lithium-ion battery. The battery is faulty, so we know that. Now I'll explain what is happening. They are 12 in number, the pairs. You have 60 volts. On the first LED you have a voltage drop of 9, and this was 9, 9, 9, and another pair which you have 9, and it takes you about 60 divided by 9, you get about how many pairs do you get? You get about 6.5, which means 6 pairs. So 6 pairs have got sufficient voltage, because this is 9 volts. When you add all of these, when you add these voltages, you get about 60 volts. Now this one gets 0 volts, and this one is 0 volts. So this acts as a barrier. These other pairs here act as a barrier to accessing the ground, which is this is the ground terminal, which is connected to this final pair. So if the current does not flow through, none of the LEDs will work. So what we have done using that small jumper is that we have counted 6 pairs and connected them directly to the ground. So we have bypassed these LEDs. Alternatively, we have also connected, in order to check whether these final LEDs that are not working when you have made a jumper, in order to check these ones, we have counted 6 pairs from this side, and then we have made another jumper to the positive side. So you have power supplied from the middle to this portion, and as you've seen it, it works, and so there is no problem with the LED. So the problem is either with the power supply or with the battery. Now with this kind of light, when the battery is bad, it tends to draw too much power from the power supply, and that's why the power on the LEDs is not enough. Now to make this one work, we can disconnect the battery. These are the wires connecting the battery, like that, and we will check, and as you can see, we have enough power on the LEDs. Now with this one, we are able to check what is the voltage now. What is the voltage on the LEDs? And as you can see, we have about 100 volts, 102 on the LEDs once you unplug the faulty battery. Now, as you can see, only the inner LEDs work. The outer ring of the LEDs does not work, because the outer LED is the one that uses the battery. It only works when we have a power outage. So are we going to leave the outer LEDs like that? No, we are going to try to use them. Now how? I will check the charging voltage of the LED. Now the charging voltage, you be very careful. The charging voltage of the LEDs has to be about 4 or 5 volts, because it is a 3.6 volt battery. So we are 3.6 or 3.7 volts. So the charging voltage has to be about 4.2 or about 5 volts. We'll check. It's about 13 volts, which is of course too high. I don't know why. It's supposed to be about 5. Let's plug in the battery. The LED goes off. We have got 0 volts. The LED comes on. We have got 13 volts, which in my opinion is just too high for this kind of battery. Now I have got these batteries, but I'm not going to replace it because with 13 volts it's still going to fail. So we are going to use this voltage, the charging voltage, to light up the LEDs that had previously been connected to the battery. So we will take that one from power. We use this one. Cut this one, and we'll make a we will connect it like that. Then we use a resistor like this one. Okay, what I'm going to do is that I'm going to connect the charging voltage, the battery charging voltage, to these LEDs that previously used the battery, and I'm going to do it through a resistor. If you connect directly, you are going either to burn the LEDs or to destroy the power supply. So you must use a resistor. Well, I've prepared these resistors, 3 of them together. This is a 20 ohm resistor, this is a 10 ohm resistor, and the other one is a 20 ohm resistor. You can do the math, it's about probably 5 ohms in total, because they are connected in parallel. Okay, so I'm going to disconnect. I'm going to disconnect this one like that. and I'll and as you can see, I have disconnected the LEDs on the outside. You can see they are not working, and I use these resistors which I connect to onto the battery charging voltage, and you can see they are working. And it slightly increases the brightness of the bulb. Of course, those LEDs are not as bright as the other high power ones that are supplied by the power supply. Like that. And then like that. And now we've got there it is. So we are not going to use the backup system anymore. So there you have it.